we proceed to solve a few logarithmic and exponential equations. Now, I haven't written down a date or anything on this series, but this is 17, 0411 document. Okay. So we have log of negative 2x plus 1 equals 1.09. How do we solve this? Well, we can easily invert this, right? We can say this is, first of all, log base 10 of negative 2x plus 1 equals 1.09, which then means that 10 to the 1.09 equals negative 2x plus 1. Okay? Now, how do we solve this? People have more difficulty with this than anticipated, so we want to make sure we understand the algebra involved. We subtract 1 from both sides. That's going to get rid of this 1. Now, see, what we want to do is we want to isolate x, don't we? So we have to use the rules of algebra. We can add or subtract the same thing to both sides, so we get rid of that 1. Subtract 1 from both sides, and you end up with negative 2x. Now, of course, that's equal to 10 to the 1.09 minus 1. Then what do? And people have trouble answering this, so you really got to get clear on how to solve linear equations. Something we kind of assume you know how to do, and you certainly do if it looks right. But if it looks a little weird, well, that's why we want to reinforce the rules here. Okay, so we divide by negative 2. That's how you get rid of something that's multiplied by x. You divide by it. So we have negative 2x divided by negative 2 equals this right-hand side. All of this divided by negative 2. So we divided this side by negative 2, and we divided this side by negative 2. Okay, well, negative 2x over negative 2, well, we've got negative 2 over 2 times x, which is 1 times x, that's x. And that equals just what it was before, 10 to the 1.09 minus 1 divided by 2. Now, what's 10 to the 1.09 power? I can't estimate that very accurately, although if I thought through it, I'd be able to use a very approximate Taylor series to do it. But you got to punch that into a calculator. Now, I just noticed one thing. I had a negative 2 here, and now the negative is out here, and we understand that, right? Dividing by negative 2 gives you the negative of what you would have if you divided by 2. So we evaluate this numerator, we divide by 2, and we change the sign. And we have our value of x. And then we can substitute that back in here. Put that value of x in here, evaluate negative 2x plus 1, punch the log key, and see if you get 1.09. If you don't, then you did something wrong. And people really tend to skip the checking step. So don't skip that step. Okay. Equation 2 to the 3t plus 2 equals 4. See what you can do with that. I would pause. And then hopefully you already paused and wrote out what you think. So let's see. 2 to the 3t plus 4 means log to the base 2 of 4 equals 3t plus 2. Log to the base 2 of 4 equals 3t plus 2. And I wrote the 3t plus 2 on the left because usually the variable that we solve for is going to be on the left-hand side of our equation. Okay, so we solve that. Okay, what do we have to do? It's very similar to what we did before. We have to isolate t. We've got a plus 2 here. We can subtract 2 from both sides. And we end up with 3t equals log base 2 of 4 minus 2. And then we can divide both sides by 3. And that gives us t equals log base 2 of 4 minus 2 divided by 3. Okay, there's our solution. You can punch that into a calculator, although it's not really necessary. Now, I didn't do this in class because I always like to do something a little extra. What's log base 2 of 4? Well, if you make the 2 to the x table and invert it, you'll find 4 on this side, and next to that, you're going to have 2. Okay? So that equals 2 minus 2 over 3, which equals 0. Okay? Since 2 to the second power is 4, then the log base 2 of 4 is 2. And you might think that through. Now let's see if that works. Plug 0 back in for t, you get 2 to the 0 plus 2, which is 2 to the second. What's 2 to the second? It's 4. So, t equals 0. We've solved the equation to prove this. To get this solution, we've plugged it back in and proved that it's so. Okay, another one. Now there's a little curve in this one. Yeah, just a little something extra. We have natural log of 3t minus 2 plus 5 equals 3. And people were kind of stumped on this, and I'm not surprised. This is, once you see it, it's really easy. Until you see it, it's not so easy. So what are you going to do about that? Well, our rules tell us that if we have log to the base a of b equals c, then we can change that to the exponential a to the c equals b. Okay, but we don't have log of something equals, do we? So we have to have the log expression, single log expression all by itself on the one side of the equation. Preferably the left side, because that's where we're used to seeing it, but either side once you get used to the rules. So how are we going to manage that? Well, how do we get natural log of 3t minus 2 on one side of this equation? Well, if we subtract 5, then we're just going to have natural log of 3t minus 2 here, right? Okay? Now, of course, we can't subtract 5 from this side unless we do it to this side as well. Okay? So, well, first we write natural log as log base e of 3t minus 2. Then we do what I said. You subtract 5 from both sides. Now, that 5 is going to go away. You're going to end up with a negative 5 over here. 3 minus 5 is negative 2. So we have log base e of 3t minus 2 equals negative 2. And now it's really easy to invert this. Just e to the negative 2 equals 3t minus 2. 3t minus 2 equals e to the negative 2. Now, how do you solve that? Well, that same scheme we used here. Add 2 to both sides. You get 3t equals e to the negative 2 plus 2. So that you can then divide both sides by 3 to isolate t. You're going to get e to the negative 2 plus 2. All that divided by 3. And if you want an accurate determination of that, you use your calculator to get e to the negative 2. Okay? 0.14, something like that, 0.13. Okay. Another equation, 5e to the 4t minus 1 equals 10. What are you going to do with that equation? Well, you've got to get e to the 4t minus 1 equals something, and then you can invert it. So divide both sides by 5, and that's what you get. And it's very clear. Divided both sides by 5, 10 over 5 is 2. 5's divide out here, give you 1, and you don't have to write that down. So you get e to the 4t minus 1 equals 2. And then we translate that into a logarithmic equation. 4t minus 1 equals log to the base e of 2. And of course, log to the base e of 2 is the natural log of 2. You want to write it like that because you can punch it into your calculator. Okay? Then, of course, you add 1 to both sides. You're going to get natural log of 2 plus 1. And then you're going to be left with 4t. You divide by 4, and you get natural log of 2 plus 1 divided by 4. Now, you can do that. And if you remember that natural log of 2 is close to 0.1 or 0.7, that's going to be like 1.7 divided by 4, about 0.425 or thereabouts, about 4 1/4. You put that in here, and you find that it works out. Okay. Now, still another curveball in this equation. So we're going to come back to that because this video is getting a little long. I don't want anybody to fall asleep on me.